Hello everyone. This week we'll be talking about law of cosine, which is the last section of this chapter. Last video we talked about law of sine, which is used for the cases for ASA, AAS, and the ambiguous case ASS. And law of cosine will be used for two cases remaining, which is the SAS and the SSS case. Okay, and as you guys can see in this diagram here, we have 6 formulas for law of cosines. But ultimately, you only need to remember one of them and you'll be able to derive the other ones. Okay, so let's take a look at how let's take a look at the formula. Let's maybe pick this one. Okay, so a squared is equal to b squared plus c squared minus 2bc cos a. So here, the side we want to find is a. This is the missing side. We want to find the side. To find the missing side, here B and C are the two other sides. So you would add the two other sides squared and minus 2 times the product of two other sides with cosine of the opposite angle of the missing side. Let's see if it's the same for the other two formulas. So for this formula, we can see the missing side we want to find is b. And so we would have two other sides, the sum of the squares of two other sides. So this is b, and a squared and c squared are the squares of two other sides. So you add them, and then you subtract 2 times the two other sides, and then times cos the opposite angle of the missing side. So this one is in exactly the same form as this one. Okay, let's check out the last one. C is the missing side, and so A and B are the two other sides. So to find the missing side squared, it will be equal to a squared plus b squared, which is the same as this part, and then subtracted by 2 times those two sides. So 2 times a times b, and then times cos opposite angle of that side. So cos c. So we can tell that all of these three formulas are in the same form. It's just that the sides are different. But if you memorize this formula, you will be able to derive the other two formulas. Okay. All right. So let's take a look at where this one comes from. Okay. So this one comes from isolating the cos A here. We can do that from this formula. Let's try to isolate cos A. If you don't want to memorize the formulas, you can try to isolate it. If you are good at memorizing, then you can skip this part, just memorize the formula. So to isolate cos A, we'll need to move the b squared and c squared away first. Let's do 2bc cos A equal to b squared plus c squared minus a squared. So here I move this term to the left side, and I move the a squared to the right. Okay, so to isolate cos A, I'll need to divide both sides by 2bc. I'll need to divide this factor here. So cos A then is equal to b squared plus c squared minus a squared, all divided by 2bc. And so if the question asks you to find the angle, you can just plug in all the sides into this equation and use arc cos, that's shift cos, to find the angle. Okay, so that's about the formulas. There is a derivation of the cosine law. You guys can check your workbook. That's on page 299. You can see how they derive the law of cosine. It's not very hard. You guys will be able to understand it just by looking through the derivation. All right. Next, we'll be doing two examples to see how we can use the law of cosine for the two cases, SSS and SAS. So the first example here is a SSS case. So same thing. To do a question like this, I'll draw a diagram first. A is 2, the shortest, C is 4, the longest, and B is 3. And let's label the angles. So that's B, this is angle A, and this is angle C. And the question asks you to find the three angles given side A, B, and C. How do we do this question? We know that if you're given a SSS case, you'll be using the law of cosine to find the angles. But what's the best way or what's the easiest way to do this question? There is an easy way to do this question. That is by finding the largest angle first. Let's write that down. Oops. Always find the largest angle. Why is that? The reason is that if you find the largest angle, it will guarantee that the other two angles are acute, so they're less than 90 degrees. How is that useful? It's useful because if you're guaranteed that those two are less than 90 degrees, then you can use the sine law of sine, to find the other two angles. Because what sine law gives is that the angles that are calculated using the sine law are always acute angles. They're always less than 90 degrees. Okay? And you guys should know that sine law are a lot easier than cosine law. So it's ideal to use sine law when possible. You guys will see what it means. Let's do this question first, looking for the largest angle, which is angle C. Okay, so we know that to find angle C, we can use the formula that contains cosine C. But I couldn't remember the cosine C formula, so I'll use the original formula first and then derive cosine C. So I know C squared is equal to A squared plus B squared. That's the squares of the two other sides added and then subtracted by 2 times the product of the two other sides times cos C. Okay, so you can either derive cos C first and then plug in the values, or you can plug in the values here and derive for cos C. So here I'm just gonna plug in the values. B is 3 squared minus 2 times 3 cos C. That's 16 equal to 4 plus 9 minus 12 cos C. And so 12 cos C is equal to -3. And so cos C is equal to -3 over 12. And so C is equal to 104.5 degrees. We know that C is equal to 104.5 degrees, and we will be able to find angle A and angle B using the sine law, because now you would have angle side angle, which is cases for sine law. So let's find angle B first then. So if you still remember from the last video, sine B over B is equal to sine C over C. Sine C is 104.5 degrees, and C is 4. So 4 sine B is equal to 3 sine 104.5 degrees. Sine B is equal to 0.726. And so angle B is equal to 46.6 degrees. So we know angle C, we know angle B, it's easy to find angle A. Angle A is equal to 180 minus 104.5 minus 45.6, which is equal to 29.9 degrees. Okay, so that's it for this example. Just remember to always find the largest angle first, because if you find the smaller angle, one of the other two angles might not be acute. So if you use the sine law, then the angle you find might be the wrong angle. All of the SSS cases will have solutions, except for one case. That is when the sum of the two shorter sides of a triangle are less than the longest side. So for example, sides 4, 5, and 10 will not work, because the longest side is 10, but the sum of these two sides is 9, which is shorter than 10. These three sides will not form a triangle. So if you see a case like this, you will not have any solutions. Example 2. Solve triangle ABC given angle A equal to 41 degrees, B equal to 11, and C equal to 6. The question asks you to solve triangle ABC. It means to solve for the missing values for this triangle. So this triangle gives you the angle A, side B, and side C. So we're still missing angle B, angle C, and side A. Let's draw this triangle first. We know angle A is 41 degrees, and so this is angle A, this must be side A. And angle B is longer than angle C, so let's make this one 11 and this one 6. And so this is angle B, this is angle C. Now let's solve for the missing side first. We can use the cosine law. So we know a squared is equal to b squared plus c squared minus 2bc cos a. And so a squared is equal to 6, 11 squared plus 6 squared minus 2 times 11 times 6 cos A. A is 41 degrees. So 57.4. And A is equal to 7.6. A is a side of a triangle, so it won't be negative. Let's just account for the positive answer. Now we know what A is. We know the two other sides. We know one of the angle. We can find the other two angles using the sine law. Remember that sine law always gives the angles that are less than 90 degrees, so acute angles. If you look at B here, B is the largest angle, so it might be obtuse. It might be greater than 90 degrees. So a safe angle to solve for will be angle C because it will be less than 90 degrees. It will be an acute angle, so won't have any ambiguous case here. Let's solve for C then. So sine C over 6 will be equal to sine A, so sine 41 degrees over A is 7.6. Use cross multiply. 7.6 sine C is equal to 6 sine 41 degrees. And so sine C is equal to 0.518. And so angle C is equal to 31.2 degrees. We know angle A, we know angle C. Angle B will equal to 180 minus the two angles, which is equal to 107.8 degrees. If you were to calculate angle B first using the sine law, the answer you get will be 72.2, which is an acute angle. That is not correct. And to solve for the angle B, then you need to use 180 minus the answer you calculated. And so to solve for angle B, you use 180 minus the acute angle you solved in order to find 107.8 degrees. So one thing you need to remember from these two examples is that sine law always gives angles that are acute. Here is a summary of the sine law and the cosine law, which is from your workbook, page 301. Given the cases, this chart tells you what method or what steps you should be using to solve for the triangles. You can solve for the triangles using this chart. Your homework is section 7.6, questions 4, 5, 6 to 8 left column, 9 to 14 every other questions. You can try these and see if you're able to do them. If not, then you can let me know during the office hour. I'll be able to help you.